Hello there. Welcome back to my channel. Today I'm going to show you one particular use case where we will take in a business requirement and convert it into a functional design document, which will be useful for uh, people to develop applications around that business requirement. So let me show you that how it works first, and then we'll get into the details as to how I have designed it and how you can also design such a application. Okay, so let me start by running the application here. So just type in this command and press enter, and it will take a little bit of time to load up. So you can see it is. We'll go back to this window. So you can see it's running on the local host. So it will automatically open up a browser window, which will look like this, and it will again take a little bit of time to load. So once it loads up, it will give you a window like this with a text box and a button to generate the document. So in this text box, we need to write the business requirement. So I have already written a business requirement here, which says the retail company wants to implement a real-time inventory tracking system across all store locations to prevent outs, optimize reordering and improve customer satisfaction. The system should integrate with the POS and warehouse management system, providing alerts for low stock items and generating automated restocking orders based on sales trends. So I'll just copy this and paste it here, and then I'll press the generate document button, and you can see it has started generating the document. So I'll go back to the window from where I have run this, and you will shortly see some logs here starting where it will tell me what it is doing. So I'll explain this in a bit, but for now, what you need to know is that this document that is going to be generated will have multiple sections like introduction, solution overview, integration requirements, and everything. And this will run through all this and then generate the document and give me a link to download the document in this window. Here it will come. Okay, so I'll pause the video here because it will take a little bit of time to run this entire program. So I'll come back as soon as the document is generated and try to explain to you as to how this happened. So now you can see that the document has been generated. I can download it from here, but before I download, I wanted to show you the logs. So this is the log basically. As you can see that there are multiple sections, right? Like for example, generating section, system configuration, and all that. So once how it works is that once a section is generated, the output is sent to a quality feedback agent, which checks the quality of the output and suggests improvements, and then sends those suggestions to the agent which is generating the section. All the sections are being generated through individual agents. It's not one agent generating all the sections. So uh, multiple sections are being generated by multiple agents. So the agent takes in that feedback, tries to incorporate those feedbacks, gives another output, and again sends it to the quality agent, and it again checks if all the feedback has been incorporated or not. If not, it again suggests some improvements and sends it back to the agent which is generating that section output. And again the agent generates the new output and sends it to the agent. The agent then says that it is okay or not, and this goes on for two iterations. After that, the output is consolidated and put into the document as an output. So this continues for all the sections in the document, and finally it generates the document. Now let me download the document and show it to you. So I'll just download it. So it has been downloaded. It's getting downloaded rather. So I'll just open this file now. Okay. So this is the document which has been generated. So you can see this is a functional specification document. It has also provided a name for this document or the project or the requirement. And then if we go down below, it has specific sections like introduction, objective, and scope. Of course, this can be better formatted, which will take a little bit of more time and effort. So I didn't go into that. I just wanted to show you how this is possible for now. Of course, the formatting and all can be taken care of later. Solution overview, and these are the major sections actually which are in blue. So functional specifications, then system configuration. This is a bit of a long document actually. Other system requirements, integration requirements, data requirements. So this is how the document will look. So this will be a good starting point for the developers to understand in a better way the requirement coming in from business using AI. Okay. So in the next section, we'll go into how this has been built, what is the structure, how the code is written and organized, and all that things. Okay.
It's all about AI.
So let's first understand as to why a functional design document is needed. So first of all, it clarifies the requirement, converts a high-level business requirement into a detailed, actionable, functional logic. Then it aligns with business and IT because it acts as a bridge between business and IT. Business is going to give you a high level requirement, and how do you convert it into an IT requirement, or in technical terms, how do you write a code and give them an application to use it? So that is where this document comes in as a bridge. Then it also acts as a development guide for the developers to read through the document and understand actually the business requirement and how the system should behave. Based on that, they can go ahead and design the system, write the code, and all that. It also acts as a validation agent, or kind of a validation document where if there is any confusion between business and IT as to what was the requirement and what is given as an application to back to the user or the business, it can act as a validator between these two, because sometimes it is difficult to like match the requirements with the application. So it then can, and this document then can be used as a validator as between the actual requirement and the output app. Okay. So it also standardizes the design. Of course, this entire app can be also built using a RAG model, where we can connect it to a vector database, or maybe upload a few documents based on which the system can build an application uh, based on certain organizational standards which can be mentioned in those documents. Okay. And then it can also support testing, in the sense that the testers can know what is the application supposed to do and what needs to be tested to satisfy the business needs. And of course, last but not the least, it creates a reference for everybody in the organization as to what was the requirement, what has been built, is it matching the requirements and the application that is getting built. So this is why a functional design document is needed and is critical in a business scenario. So now let's look at how this has been built. So I'll first try to describe the files and folder structure. Um, of course, the high level folder is the functional specifications generator folder, under which we have the app.py file, which is a Streamlit front end UI, which you saw where we copy pasted the business requirement and pressed that button to generate the document. Then comes the crews, which is, I named it crew in the sense that it's a crew of agents. It has nothing to do with CrewAI, so don't get confused. So it's a crew of agents uh, which will build the document. So this document crew is kind of orchestrator of all the agents, and also loops through that quality agent that I already described in the earlier section. And then comes the utils folder, under which we have a lot many files. First is init.py, which marks the entire folder as a Python package. Then the .env file, which contains the OpenAI API key. And then comes the document generator, which builds and saves the MS Word document. Then the get OpenAI key, which is a kind of a Python program which takes the API key from the .env file and passes it onto the program so that it can communicate with the program and give the output. Then comes the LLM wrapper, which wraps the GPT-4o model, which I am using here to generate the output. Then comes the logger.py, which is a logger or kind of logging file which logs what is happening and all that, so that we have a trace back as to if the program is working properly or not. Then comes the project title generator, which generates the title as I showed you in the first page. And then the prompt templates, which stores all the prompts for specific agents to work in a synchronous manner. Then comes the agents folder, which contains all the agents. Like I said, the document will have multiple sections. So for each section, there is an agent. Like for example, introduction section, project scope agent, and then solution overview agent, function spec agent, system config agent, other system requirement agent, integration agent, and some data requirement agents. And finally comes the quality check agent, which takes in input from all these agents, tries to see if the output from these agents can be a little bit better, passes on feedback and loops through for 2 times to make the output better before it passes it on to the this these files, actually the basically the doc generator file, so that it can combine everything and put it into the document and give us the link to download it. And lastly, the requirement.txt file, which contains all the requirements packages that need to be loaded, basically Python dependencies. And then the environment folder, which has the virtual environment details. So this is how the folder and the directory structure looks. I'll move on to the next one. Okay, so I'll just go back to the earlier slide. Okay, so this is how it works. Basically, this has all the definitions for all the files that are there. Like for example, the app.file is a Streamlit UI, the browser window that you saw that has been built by this file, which accepts the input and allows us to download the final document. Then under crews, there is a document crew which orchestrates all the agents, handles quality check loop, the quality agent loop, and all that is handled here. Then the init.py marks the init that utils folder as a Python module. Then the .env file, as I already said, it stores the API key. And then the doc generator, which generates the final MS Word doc with formatted sections. Then the get OpenAI key, which reads the API key from the .tnb file for LLM usage, which is in this case chatgpt-4o. And then the LLM wrapper calls the GPT-4o with prompts and returns the clean output. Then the logger, of course, logs everything in a log file and also shows the output on the screen. Then the project title generator, which generates the title as I showed you on the first page of the MS Word document that got generated. And then the prompt templates, which stores the reusable prompt templates for all agents and quality checks. And then comes all the individual agents for individual sections. Like introduction agent generates the introduction section, the project scope agent generates the project scope, and so on. And like this it goes on till the data requirement agent, which generates the data requirements. And finally the quality check agent, which checks for the quality for all the agents and provides feedback 2 times, as I said. And then finally comes our requirement.txt, which lists all the Python dependencies to install. And then the virtual environment folder, which contains all the Python related virtual environment details related to Python. So I'll move on to the next slide, which talks about what kind of agents or framework I'm using here. So I'm particularly not using any kind of agent or framework here, like a CrewAI or N8N or AppGen or or Langchain, anything like that. I'm just using plain simple Python classes with a run method which receives input business requirement plus optional feedbacks from the quality agent, and then it uses the prompt in the sense the business requirement calls the GPT model through the LLM wrapper file that I discussed a little bit earlier, and then it generates the output basically. So I'm not using any particular framework but just Python classes here, and I have put all the Python separate Python classes for individual sections and name them as agents in this all overall folder structure. Okay, so how does this work? Okay, so let's go step by step. Okay, step one, the user opens up this app, which is like runs the app, and it is run from app.py. So once it runs, what happens? The UI loads up, the user interface or the browser window I showed you. It loads up and it gives us a text area to paste the business requirement. And where does it come from? Again, the app.py file. Then the user submits the requirement and presses a button saying generate a document, which again comes from app.py file. Then it initiates the document crew object, which is kind of it starts calling uh, all the agents or the framework I have designed or Python classes that I have designed in individual files. So this is the main orchestrator agent, document crew, which basically uses which is basically acting as a orchestrator. Inside the document queue, all section handlers like agents are initialized using a common GPT wrapper, which is a LLM wrapper. So from document queue, the LLM wrapper gets called, which actually calls the LLM, which is GPT in this case, and then also calls individual agents so that the output is generated and the wrapper is able to wrap it and provide it in a presentable format. Okay, then what happens for each section, introduction, scope, etc., the section agent generates a draft for the from the requirements or the business requirement that it has got. It generates a draft, it sends it to the QC agent or the quality check agent, which reviews the draft. After the quality check agents give some feedback, and which is rechecked and regenerated, and this continues for max of 2 times, right? So what are the files involved? Document crew py, and then the agents, all the agent files that I showed you. So the prompt templates, because the agent file calls in this prompt templates to get the prompts from here, and then the LLM wrapper wraps it up in a presentable format. After all the 8 sections are finalized, they are returned as a direct as a dictionary, section name and content. How this is done? Again, this document crew, which is the main orchestrator, it passes the output as a dictionary, and then the GPT helper function extracts clean project title from the original requirement or the business record that has been passed on, again is passed on to GPT, and there is a file called project title generator. Based on the business requirement, it generates a project title out of it, which I showed to you on the first page of the document that was generated. Then comes the doc generator again. Not again. This doc generator gets called, which creates all the sections, plus the title and everything using the Python docx package. Okay, then the user is shown the download button, where the user can press and download the docx file. Again, this is called using the app.py file. So this is the overall flow based on all the files that has been created. So again, just to give you a glimpse of how this works, so the user provides an input into Streamlit, and then the document crew got called, which is the master coordinator or orchestrator, which runs each agent. each agent in the sense the introduction agent, the functional scope agent, and all those, which then passes each of the agents and it goes in a synchronous way. First, the intro is generated, it is passed on to the QC agent for review. It passes on the feedback back to that agent. It regenerates and again passes on to the QC agent, and again it reviews and sends it back, like again for regeneration. This in this way it continues for two times for each of the sections for which the agents has been defined. Okay. Then after that, after all the sections are generated, it is finally put into a Python dictionary and passed on uh, passed on basically to again the document generator here. But before that, project title is created based on the business requirement that was given. Again, the business is passed on to GPT, which summarizes the business requirement and creates an project title, which is put on the first page of the document that I showed you. Lastly, Streamlit creates a button to download the file. So this is how the entire thing works basically. And if you need the code for all this file, please feel free to connect with me over LinkedIn, or leave me a comment below so that I can contact you and provide this all the code that I have written here to generate this app. So I will now go into the file structure that I showed you. I'll show you the details as I promised. So this is the main functional specification generator folder, under which there is agents folder, which contains all the agents including the quality check agent here. And then the crews, I've just named it crews because it will handle all these agents, so just named it crew. Again, I repeat, it has nothing to do with the CrewAI framework or anything. And then comes the utils folder, which is a package kind of a thing I have created with the .env file and the doc generator, get API key, and the .env file, LLM wrapper, logger, and the project title generator and prompt templates as I showed you in the PPT. And finally, the app.py file, which is the py file, which is the main Streamlit front end generator basically. And the output doc is kept here. So every time a new output is generated, this file gets updated or overwritten basically. So, in a nutshell, this is how this works. I hope you find this useful. Again, I repeat, if you want the code for this file, please ping me please connect with me on LinkedIn, or just leave a comment down below. And if you want me to work on any particular use case and give you a similar kind of application build, please feel free to contact me. So I'll try to do that. And also let me know what next you want me to build and show you and give you a demo. So that's how it is. So with that, we come to the end of today's video. Thank you for watching, and until my next video, have a nice day.